Ben Pearson, the Roaster Tracker. In pretty much all of the United States, with a few exceptions, we had some absolutely frigidly cold weather here, and that had all kinds of effects. One of the biggest areas that had an impact was that of Texas, and I wanted to talk about that because there were a lot of really interesting things that happened there that's definitely worth some consideration. Now, we've previously talked about the electrical grid, and if you want to know all of the details, you can see my video on that. But the bottom line is the situation in Texas led to 5 days of massive rolling blackouts where there just wasn't enough power generation possible to heat everything up. And it also led to skyrocketing prices. Some people were paying as much as $9 per kilowatt hours for days for any use of electricity that they had. And so using that knowledge that we gained previously with the price of the grid, we're going to take a look at that situation and try to understand what really happened there, because there's an enormous amount there. So first of all, there are 3 major electrical grids in the continental United States. You have the East Coast, the West Coast, and Texas. Texas has its own grid that's separate from the rest of the nation for a couple of reasons. There were some historical reasons. These days it's primarily because if they connect up with the rest of the country, then they have to follow the interstate regulations. Congress here in the United States is only allowed to make laws to regulate interstate commerce. So if you keep an entity entirely within a state, they can't force the state, generally speaking, to follow those laws. And so Texas has been able to do this, and they've been able to shy away from some of this regulation, which has led to some lower than normal electricity prices, generally speaking. There's a couple of other things that we need to know. First of all, there is a service called Griddy, which has made news. They had some spectacularly high prices for its customers. Let's understand what Griddy actually is. Griddy is a virtual power system that they charge $10 per month, and that's it. That's the entire amount of money that Griddy will ever make. The rest of the money that's on your electricity bill is exactly what Griddy is paying to provide the electricity. They will charge that to their customers. So that way they're just passing on the cost. And there's actually some times of the day where if you charge, you may actually make money. And there's plenty of times in your typical day where you're barely paying anything for the electricity at all. And so if you're really smart and you follow this carefully, you have the potential to save a ton of money. And so a lot of people have been switching to that kind of plan. And this is actually a good thing for the electricity. When electricity is cheap, it's basically because there's a surplus, and it's a good thing to be used. And you can avoid the higher demand periods of time because it would be more expensive, which will help to, over time, even the load of the grid. If I could have the ability to charge my electrical car based off of the actual raw grid prices, that would be fantastic. Now, how do the prices actually work? Now, again, I mentioned that previously in my video, but there is a very, very complex system. And the system essentially comes down to, you have a number of power companies that are putting in a bid. They're saying, I can charge this much for electricity, and this is what my costs are. They don't actually take into account a profit. They just say, this is what it's going to cost me in terms of the fuel, in terms of the manpower, etc., to produce electricity at this time of the day. And this is how much I can produce. And given that, they will find what's called the margin price. The margin price is the lowest cost of the electricity to supply the needs of everybody. And every single power plant, regardless of what they bid, will receive the margin price. So they'll receive at least enough money to cover their costs. Now, there's some other things like capital expenditures that are dealt with in a different way. And there's also some real-time adjustments. Typically, this market happens a day in advance if you can predict it. But the predictions are not always accurate, and so they are trying to adjust those in real time. But it still remains the same, that wherever the price is of electricity, everybody pays that, and they pay it to the generator. So it doesn't really matter which way you do it. And that's kind of the capitalistic way to do it. That's the way that all of the major grids in the United States work, and I think most of the world, although I haven't extensively studied some of these other grids. Of other note, it's also worth noting that sometimes having a large connected grid can cause problems. In 2003, a problem happened in the northeast part of the United States that would have theoretically been quite localized, but it managed to take out a significant portion of the power grid of the entire country, the northeast part of the country, for a day or two. And yeah, that caused some issues. But luckily that happened in August. It was relatively cool. That's a great time of the year for that part of the country, so AC heating wasn't really an issue. And people just had to live without electricity for a couple of days. But when you have a severe weather event like happened in Texas, if you don't have a way to heat your house, that can be a very, very serious, dangerous problem for a number of reasons. First of all, it can be dangerous to life, and second of all, you can have frozen pipes, and those frozen pipes can burst and cause all kinds of damage. So there is an enormous amount that goes into this. A couple of other factors. The price for electricity in Texas caps out by law at $9,000 per megawatt hour, which is $9 per kilowatt. Now think about that. If you're running a little 60 amp light bulb, your typical incandescent light bulb that you would find, then at that price, you're paying something like $1 an hour just to run that light bulb. That's insane, okay? Normally, it just costs you a fraction of a penny to have that light bulb on for an hour. You can have 50 of them in your house and you'll just pay a few pennies to run that. But it costs a significant amount of money during these peak times. And the way that this works, it works out fantastically. Some of the power sources, like solar power, actually depend on this kind of market because that's how they pay for their capital cost. They're getting the money that everyone else is, but you can't put in the capital cost necessarily, so that's how you pay for it. Now, redesigning the grid is an entirely different question. We're not even going to discuss that. You can look into my previous video on that one if you want a little bit more information on that. But what actually happened in Texas? Well, the cold started to come on the 14th of February. And it happened as it was kind of expected. The couple of these marginal plants that were charging in the realm of $900 per megawatt hour, about 90 cents per kilowatt hour, that is the unit that we more commonly use in our houses, that it'd be a high cost. But it would certainly be something I think would be reasonable to pay if you're basing it off of the grid values. It's a high risk but high reward potential system. So that seems like a reasonable cost to me, and that was kind of how things were operating normally. That's how things operated on the 14th. On the 15th, they started to hit the peak cold, and all kinds of interesting problems started to happen then. Simultaneously, you had a higher demand for electricity. We'll talk about that more in a moment. And you also had power plants that started to stop functioning. And every single type of power plant had issues. Let's just be clear about that. Now, it's true that in Texas, a significant amount of the electricity can come through wind, and wind turbines couldn't spin as efficiently because they weren't winterized. It caused some issues. Now, wind can work quite effectively in the cold. We've seen this in a lot of the European countries that are further north. It can work out quite fantastically there, but you have to properly winterize it. The thermal plants, which also produce electricity by spinning, but they do it through steam power. Steam power requires a source of water. Well, water was kind of in short demand at that point in time because everything was frozen. The intakes couldn't take in water because they had solid chunks. If you can't take in water, you can't burn steam and you can't produce electricity through thermal. Now, the thermal systems are any coal, gas, or even nuclear. One of the nuclear power plants was off. And then you have solar, which produces it by just direct sunlight. There was snow in the area. That snow covered the solar panels and thus affected them. And that covers pretty much every major form of electricity other than hydroelectric, which I don't think there's a significant amount of in Texas that I could find. But even then, hydroelectric doesn't work very well because you have frozen water. You can't really run that through your system that well. So every form of electricity took a hit. It was rough times. The price is set a day in advance if everything works well, and you also have some peaker plants that can adjust the price as needed. By the way, you also have peaker loads, which are not talked about as often. If you have something that you can run for a short period of time that you want to be able to take advantage of inexpensive electricity, you can do that. If you have like a Tesla Powerwall type system and you can tap that into the grid, you could actually charge those batteries when the prices are dirt cheap, and then you can send them out. That's how the systems that they build work. And you can kind of balance out some of these load problems that you can have. They will actually take the electricity from the grid when it's basically free, and then they'll send it out when it's more expensive, and that helps to balance the load of the grid much better and will actually reduce the cost because you're cutting some of these marginal costs that are quite high. So this perfect storm was happening. As the 15th started to happen, they started to notice the supply was going down. And so they had to start cutting off power, and you can actually see in the data there was a big drop immediately, and the power hadn't quite cut off that fast, so they reversed back. The drop in the load was not the drop in the theoretical load, it was they had to start cutting off power to people so that they could just survive the grid. The grid was in some serious danger. If they let it get completely overwhelmed, then you have massive, massive problems. And it could take days to recover with complete power outage. That's one of the contributing factors to the 2003 power outage. At this point in time, you start to get to the contingency plants, and the contingency plants tend to be rather expensive. Otherwise, they would be main plants, and they have a high cost. Now, if you think about this, if you're able to meet 90% of your electricity at a reasonable cost, and you're just charging a little bit extra for that extra 10%, that doesn't seem completely unreasonable. To avoid a rolling blackout, that makes sense that you would do that. But one of the interesting things about the power grid is that everybody is paid the same, regardless of where you are, what you actually bid. And that caused some interesting things. So a lot of people are saying, hey, price gouging. Somebody must be charging some unreasonable amounts of money for that, and they must be profiting. And don't get me wrong, people are profiting from this. But the people who are profiting from this are the power companies that were operating normally. That they didn't set forward a high expectation of cost, but they're actually getting paid something like 500 times the amount of money that they bid. They were bidding something on the order of maybe a few cents per kilowatt hour, and they're getting, $9. That's an enormous profit margin. And they did that over the course of 5 days. So what's actually going to happen? Now, I think that you just can't really make this work. Like, it's really hard. If I run a nuclear power plant, yeah, I get a windfall, a ginormous windfall for keeping my power plant active. And granted, there are some extra costs, and they have to pay for the capital costs somehow. But it doesn't really make sense to me that they would be getting that huge windfall. I'd have to look through this, but if you had a system that can generate, let's say, 1 gigawatt of power, which a nuclear power plant can easily do that, you would be making just ginormous amounts of money. You're talking $9 million per hour, which is way over their budgets. I mean, that's just huge. I think that they're going to cut those profits maybe by a factor of 10, so they're still high, and they need that money to be able to pay for their capital costs, which will ultimately reduce the costs in the area because they need these capital costs to keep up the maintenance and whatnot. But they're still just kind of crazy high. I think that the peaker plants that needed that power should get that money, and the other plants that were just operating nominally, they should expect to get something because, hey, they should be rewarded that you winterized your plants to make so they could survive this. You should get something extra, but not insanely extra, just something more reasonably extra. And if they do that, then you can take a $15,000 power bill, which is insane, and make it down to $1,500, which, yeah, it's high, but if you do a high-risk system, sometimes you're going to get screwed. And you just got to take that into account. You know, if you go and invest in Bitcoin when it's at its all-time peak, and then it drops by 10% of what it was worth, then you lost a lot of money. Yeah, you may have gained a lot, but you could lose a lot too. And I think that it's reasonable to expect that, but $15,000 is insane. So that's what my thought is, and I'm sure that in the end, something along those lines will happen. You know, the power plants that were operating nominally, I'm sure that they would love to have a huge payday, but it doesn't seem like they need that big of a payday that's 500 times what they were asking for. So nobody's really price gorging, I think, in this situation, other than a few of the peaker plants. At that point in time, you know, if I go set up a power plant and I can produce 1 megawatt hour at a cost of $9 per kilowatt hour, then by all means, they would take that and they would set that as the price for the entire grid. That seems a little bit crazy. And I definitely think that the way that the pricing is set on the grid needs to change. It's just kind of a mess right now. Thank you guys so much for joining me. Let me know whatever questions or comments you have. Let me know especially if you have a suggestion on how to better improve this. The really obvious thing is that Texas needs to connect up to the rest of the United States so that way if they have an issue, they can supply power from the rest of the country. And they can also likewise sell their electricity when it's so cheap. Electricity in Texas is frequently negative in cost because they just don't have anywhere to sell it. They have this surplus demand. And you actually sometimes have costs that are associated. Like if you have a nuclear power plant, you can't just wind that down instantly, or any kind of thermal plant for that matter. So you are producing electricity regardless, and you have to cut the cost somewhere. So this kind of problem can happen. And yeah, the price of electricity will go up because they'll have to meet the federal regulations if they do that. But the federal regulations will keep them from having this kind of disaster. If they had been properly winterized, which wouldn't cost that much money really in the grand scheme of things, then they would have worked out fine. Thank you again so much for everything. Thank you for your questions, comments, concerns that you leave in the comments, and for liking and subscribing to this. Thank you to my Discord members who I helped to bounce ideas off of. You can find a link below if you're interested. And thank you to my Patreons who help to support me in these endeavors. You guys are amazing. Until next time, keep on tracking. Take care, guys.